Hello. In this video we will be covering how to perform the J, K, SE0 and NAK portion of compliance testing for USB 2.0 devices. For this test we will be using the MSO5204B oscilloscope that we've been using in the past videos in this series, as well as two P6245 active single-ended probes and the USB high-speed electrical test tool from USB.org. This test measures DC voltage values, so it is also acceptable to use a digital voltmeter or multimeter. Here is a quick look at our hardware connections. As before, our host PC is connected to port J37 via USB, and our test fixture is powered from a USB connection to port J92. Our DUT is connected to test port J34, and our two voltage probes connected to the D+ and D- J310 pins. Make sure that the S6 switch is set to the init or initialize position at the beginning of this test. Before we begin our testing, here's a quick look at the actual test fixture connections. As before, we'll start our testing by opening the USB high-speed electrical test tool downloaded from USB.org. Reminder that you host PC may have multiple PCI buses used for your various USB ports. Also remember that this software will take over all USB ports on the selected bus. If you still want to control other attached USB devices on your host PC, you need to either make sure those devices are attached to a different USB PCI bus or use USB 3 ports instead. Now that we've selected our desired PCI bus, we need to identify our device under test. Simply plug your device into your test fixture and click Enumerate. You should see your device pop up in your selected device list. Since we're using our oscilloscope as a DC voltage measurement tool in these tests, I'm going to start from a default setup and then make sure both channels 1 and 2 are turned on. Afterwards, I'm going to configure RMS voltage measurements for both channels by going to the Measurement Setup menu and selecting RMS for channel 1 and channel 2. Now that we've configured my oscilloscope to measure RMS voltage, we can go to our electrical test tool on our host PC and select the Test J device command and click Execute. Once we've done this, we're going to flip the switch on our test fixture from the init to test position, and what you should see is our channel 1 signal jump to roughly 400 millivolts DC. In our case, the measurement value is a little bit below that, about 390 millivolts. Now, as per the spec, what we're looking for is a DC voltage of 400 millivolts plus or minus 10%. In this case, plus or minus 40 millivolts. So you can see, in this case, we pass. Now, to proceed on to test K, I need to reinitialize my DUT. So what I'm going to do is turn my switch back to initialize and power cycle my DUT by unplugging it from the test fixture and plugging it back in. I'm then going to click on the Enumerate Bus button in the electrical test tool to re-enumerate my USB and get it ready for test K. Once this is done, I can select test K from my device command list and click Execute. As before, when I flip the switch from initialize back to test, we'll see that now channel 2, which is associated with the D- pin, is also roughly 400 millivolts. In this case, measuring at about 391, 392 millivolts, still within the 400 millivolts plus minus 10% or plus minus 40 millivolt spec. As before, we need to reinitialize our DUT, so I'm going to put the switch back into the initialize position and power cycle my DUT by unplugging it and plugging it back into my test fixture, and then clicking the Enumerate Bus button in the electrical test tool on my host PC. Once this is done, I'll move on to the final test, test SE0 NAK, click Execute, and then switch the switch back from initialize to test. In this case, what we are looking for is to measure both channels 1 and 2 at 0 millivolts plus or minus 10 millivolts. So what we're hoping to measure is essentially DC 0 volts. In this case, both channels 1 and 2 are measuring at roughly 5 millivolts, so we are again within the spec of 0 millivolts plus minus 10 millivolts. This concludes the J, K, SE0, and NAK test procedure for USB 2.0 high-speed devices. The next video will focus on the suspend, resume from suspend, reset, resume from high speed, and chirp tests as per the USB 2.0 high-speed standard. As always, for any additional information and support on Tektronix equipment and test solutions, please visit our website www.tek.com/support. Thanks again for watching.